Alright, let's go ahead and get started. So, the last day I was here, whenever that was, we talked about energy. And so now I'm going to talk about heat, which is types of energy. And then we'll talk about specific heat.
What's the date for that?
October 8th.
8th?
I said it. Is there a problem?
Yeah.
What's the problem? All right.
Heat is energy in change. So when you're heating something up, you're giving it energy. So let's just write that in there too. When heat something, see, when you read this to yourself, you might be thinking, well, last time I told you that energy is movement. So if you're heating something up, you should be making it move. But you know when you put something on the stove or you put it in the oven, it doesn't look like it's moving. So what are you actually doing that's giving it energy? You're actually making the particles themselves move faster. Because you know everything around us, the air, the stuff here, right? These are made up of particles that are moving. So when you heat the thing up, when you put something on the stove and you make it hotter, particles in that thing start moving around faster. That's why things tend to expand when you heat them up, because the particles are banging into each other faster and they start spreading out. So you can add in here, literally heating up particles. By particles, I mean either atoms or molecules or whatever that thing happens to be made of. All right, so that's it for heat. Now specific heat. The specific heat is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. The amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree. So this amount, the specific heat, will be set for any given substance. So for iron, it's 0.46 joules, or for aluminum, it's 0.9 joules. And it's always the same for that given substance. It always takes the same amount of heat to raise the temperature of 1 gram of the stuff by 1 degree Celsius. Now the equation that goes along with this looks like this. Q equals MC delta T. Control it a little better. I want to explain what each of the variables is. Just write it down first and we'll go over it. Okay, so Q is heat. I don't know why we use Q for it So you ran out of letters in science, so B is Q. M is mass. C is specific heat, the thing I just explained to you. And then delta T, change in temperature. Okay, so just to explain this delta T thing, anytime you see this Greek letter delta, which is basically a triangle, it means the change in something. So if I said delta X, that would mean the change in X. So that would be like X2 minus X1, or X final minus X initial. Same thing for temperature. If I gave you two temperatures, I said the temperature went from 10 up to 40, then the change in temperature would be 30. You just do 40 minus 10. So you just subtract the final temperature minus the initial temperature, that tells you the change in temperature. All right, let's do a problem. Is everybody caught up? Does everybody have this written down? So I got to erase. Everybody not caught up with that? Okay. All right, so we'll do a few problems with this and see how it works. How much heat is needed to raise the temperature of, let's say, 600 grams of iron from 20 degrees Celsius, that's about the temperature in this room right now, to 250 degrees Celsius. Okay, so like any problem we do, we always start with the same steps. List your givens. So we have mass, 600 grams. And we have the specific heat we would look up. So I told you that this thing is iron, right? So you just look at page 508, that page that you read just now in the book, and it says in that column 0.46 in that table there. So C equals 0.46. And for specific heat, the units are going to be joules, because it's energy, right? How much energy per gram per degree Celsius, which makes sense because specific heat is how much energy to raise the temperature of 1 gram of a substance by 1 degree. So that's why we got grams and Celsius on the bottom.
What's in between grams and Celsius?
Just a dot. You can ignore the dot.
Can you redo C? Because I got lost.
Okay, so C is the amount of energy. So we put joules per units per gram per degree Celsius. So it's just joules per gram per Celsius. Again, don't get all upset about the units. Just write them in there. They're going to make our answer come out with the right units. All right, the other thing we have temperature.
Wait, no matter what problem it is, it's going to be joules and then grams Celsius?
Joules over grams Celsius, yep. Or it could be calories per gram
That's
Celsius.
defined specifically.
Yes. So I'm always going to give you these units. And then change in temperature. Well, that's just going to be 250 minus 20. So it's 230 degrees Celsius. That's how much the temperature went up by. And then the question is, how much heat? So that's Q. So, we write our equation down. Q equals mc delta T. We're looking for Q, so that's convenient because the equation's already solved for Q. So all you have to do is plug in numbers, m, c, and delta T. So here we go. M M is 600 grams times C, which is 0.46. Carry all the units along there. Times 230. And this is degrees Celsius. And before we even do anything, we can cancel out all these units. Grams cancel, Celsius cancels. So our answer's going to come out in joules. All right, questions before we multiply?
I don't think any of us understand what you're doing.
I got it.
How many people understand what I'm doing? How many people don't understand what I'm doing? Okay, so about half and half. Let's finish this problem, and then we'll talk about it. So right now, all I've done so far is I've plugged in, what is M? Well, M is 600 grams. What is C? C is that number. Delta T, well, that's this number here. So I plugged those three in. So now I'm just going to multiply these three numbers. 600 times 0.46 times 230. Who's got a calculator? It's helpful if everybody plugs these in as you go along, because as we do more complex problems, you want to make sure that you are plugging in the calculator right to get the same answer that I get.
63,480.
63,480, and the units are going to be joules. All right. So all we did is we multiplied mass times specific heat times change in temperature. That's all.
All that, I mean,
Yes.
not even
This times this times this. 600 times 0.46 times 230. So all we're doing is multiply. You don't put the units into your calculator, you just put the numbers. The units you just carry along and cancel whatever cancels. It's just the numbers. All right, let's do another problem. Two. Where's she going? I have to leave soon. I don't work the noise during the course. Okay, so, how much heat? Wait, you just heard me talking about. What are you talking about? What are you talking about? Why? How much heat is needed to raise the temperature of 250 grams of aluminum?
I have a question. Where are we finding the specific heat from? Like the 0.46?
Page 508 on the table.
Is that?
Not table, no, page 508, the table of specific heats. Well, you can Google it. You can just type in specific heat of aluminum and it'll come up.
I thought if we take out our phone, we would do it.
Not here, but at home, if you don't have a table, you can look it up. You got the book. Yeah, but I mean, if you don't have a table, you can always just Google it. It's always the same number, as long as you get the one that says joules on top. Temperature of 250 grams of aluminum from 25 degrees Celsius to 70 degrees Celsius.
Is it 10,125?
Probably, but I'm not there yet. So mass is 250 grams. Specific heat, what's that?
0.90.
0.9. Okay, so 0.9 joules per gram times Celsius. And delta T is going to be 70 minus 25, or 45. And Q is the question mark. All right, so again, write our equation down. Q is MC delta T. And all we got to do is multiply mass times C times delta T. So it's going to be 250 grams times 0.9 times 45. All right, what do you get?
$10,125.
And that's going to be Celsius goes away, grams go away, so your answer's in joules.
Is your answer always going to be answer?
Anytime you're looking for heat, your answer should be in joules or calories, some unit of energy.
So you got the like 45 and 70.
Yeah, yeah, this is just 70 minus 25. All right, how many people get it now? How many people still
I have
lost?
a question.
Yes.
Now, would it tell you if you're looking for joules or calories?
Well, for your picking which specific heat you use, I always want you to use the ones in joules. If you look at that table on page 508, the other column is in calories per gram times Celsius. I want you to use joules, so your answer will always come out in joules. All right, so we're done with that. Let's do a problem now that's a little bit different. Let's do one where you have to find change in temperature. So if we add 40,000 joules of heat to 750 grams of, let's go with the aluminum again. How much will the temperature go up? Okay, so again, with every problem you do, there's basically 3 steps. List your givens, write the equation, and then if you have to, solve the equation. We didn't have to in the first 2 problems, here we go. So, mass, 750 grams. C is what?
0.9.
0.9. That comes out of the table, because we know it's aluminum, right? Joules per gram Celsius. Delta T?
Question.
Right, we don't know what delta T is. That's the thing we're trying to figure out. How much will the temperature go up or go down? Either way, that would be delta T. And then Q, we have
40,000.
40,000 joules. Okay. Now we write our equation down. Q equals MC delta T. And what do we have to solve for?
Q.
Yeah.
I mean, delta T.
You gotta solve for delta T, because that's what we're asked. How much does the temperature change? So how do we solve this equation for delta T?
Sure.
40,000.
Nope, we're not gonna plug in numbers. We want to solve algebraically first.
You move it to the other side.
Well,
Is
The
it
delta T.
what are you gonna say?
after delta T equals 3 divided by MC?
Yeah, so what you're gonna do is you want delta T to stay here, so you need to divide by MC. Get those on the other side. So we divide both sides of the equation by M times C. You can do one at a time, but we're just gonna do both to get it over with. So this cancels, now we're gonna have delta T by itself. So it'll be Q over MC equals delta T. So the goal with any problem is just to get to whatever this thing is that has the question mark. You want to have your equation say that equals all the other stuff. So now it's solved for what we need. And now we can plug in numbers and get our answer. So it'll be Q, 40,000 joules, divided by M, 750 grams.
Mr. Primonte, please call 2501. Mr. Primonte, please call 2501. Thank you.
Times C, which is 0.9, with all those units that go along with it. Don't worry too much about the units. If you want to write this out without units, you can, as long as you know what units the answer is to be in. Okay, now, so this one was a little bit harder because after writing our givens and writing the equation down, we had to solve for what we were looking for. Now, there's one more thing where students sometimes screw up, and that is plugging numbers into a calculator. If you try doing this, if you type into your calculator 40,000 divided by 750 times 0.9, it's going to be wrong. Because what your calculator is going to do is this times this, it's going to get an answer, and it's going to multiply that answer by 0.9. And that's not right. Both of these things you're dividing by. So what you need to do is get the bottom first. So 40,000. Yeah, so you multiply these and get the number. So it should be 675. So 750 times 0.9, get an answer, and then finish the problem. 40,000 divided by 675 is what?
59.25.
59.25. And then your answer is going to be joules cancel, grams cancel. Your answer is going to be Celsius, which makes sense because it's changing temperature, right?
Wait, 59.
59.25 degrees Celsius. So that's how much our temperature went up by. All right, questions? All right, turn that off.